Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandar. Students, we have already completed two sessions in this basic electronics. This is the third one. If you want previous, click on playlist and you can find out the previous. Okay. Let us check up to which we have completed. All these are topic wise MCQs useful for both the electrical and also electronics engineering students. Okay, up to this one we have completed now. Coming to the first question in this session, in an intrinsic semiconductor is nothing but pure semiconductor. In pure semiconductor, no holes, number of holes is equal to number of electrons. Yes, it is correct one now. And electrons in the material are more than holes. There are no electrons in the material. So answer is option B. In pure semiconductor, always number of electrons is equal to number of holes, or concentration of electrons is equal to concentration of holes. We have already discussed in the previous session. Okay. The depletion region of PN junction, there are dash. Coming to the depletion region of the PN junction. What is this depletion region? Whenever the junction is forming by, here one side is doped with P type, one side is doped with N type. Here what is happening? Some of the positive will comes here, some of this negative will comes here. Okay, so it may be having immobile positive and negative ions. Immobile positive and negative ions. So these are immobile. So that's why this depletion region may not allow the electricity through this one like a conductors. Okay. So because of these immobile and positive and negative ions, it formed a region. That region is called as depletion region. Coming to the next one, very important question guys, immobile, positive and negative ions. Resistivity of semiconductor depends upon dash. We know very well resistivity depends upon nature of material or type of material and also temperature. Okay, but not depend upon any physical quantities. Length, it may not depend. Cross section area, it may not depend. Volume, it may not depend. Okay, all these are physical quantities. Length, area, volume. Okay, it may not depend upon all these. Atomic nature of the semiconductor, that is type of material or nature of material. Okay, in pure silicon, major part of the drift current is due to free electrons because of dash. Why the major part is due to free electrons? We know free electrons can move faster than the holes. The mobility is higher. Mobility, already we have discussed in the previous. Mobility of electrons is greater than mobility of holes. Okay, so that's why the major part of the current is flowed due to electrons. So mobility of electrons is greater than the mobility of holes. Okay, mobility of electrons is greater than the holes. Okay, for example, if you can consider germanium, the mobility of electrons is in the order of 3800 centimeter square per volt second. If you can consider holes, that is just 1800 only. That is nothing but like a 2.1:1 ratio. That means almost two times, twice. Okay, electrons moves twice that of the holes. If you can consider silicon, 1300 order, and that is mobility of electrons. Mobility of holes is nothing but 500 order, I think. Okay, 500 order. That means you will get approximately 2.6:1 now. 2.6:1. So almost you can say 2 or more than 2. That's why most of the current is due to free electrons only. Coming to the next one, in the following which indicates mass action law. Very important one. Mass action law. The product of N into P is equal to constant. That constant is nothing but intrinsic concentration square. So NP is equal to Ni square. Very important relation. Sometimes in the problems they will give Ni, NRP, any one, and asking other quantity. Okay, so NP is equal to Ni square. Ni is nothing but intrinsic concentration. Okay, so we have the values for intrinsic concentration, that is 1.5 into 10 power 10 centimeter power minus 3 for in case of silicon. In case of germanium, it is 2.5 into 10 power 13 centimeter power minus 3. Okay, so for germanium 2.5 into 10 power 13, silicon 1.5 into 10 power 10. Okay, so in the PDF I have given all the differences between silicon and germanium. Try to download the PDF. Here answer is NP is equal to Ni square. Coming to the next question, a specimen of intrinsic germanium with the density of charge carriers of 2.5 into 10 power 13 centimeter cube is doped with one donor impurity atom such that there is one donor impurity atom for every 10 power 6 germanium atoms. The density of germanium atoms is 4.4 into 10 power 22 per centimeter cube. The whole density is dash. The whole density is dash. So they are asking P, they are asking. Okay, so we know NP is equal to Ni square. So what is the N they have given? N is nothing but coming to the density of germanium atoms for every 10 power 6. So that is 4.4 into 10 power 16 you will get. Okay, so from this P is equal to Ni square by N. Ni, this is the intrinsic concentration, 2.5 into 10 power 13 whole square by 4.4 into 10 power 16. This is 10 power 26. 10 power 16 comes to the numerator minus 16. 26 minus 16, 10. Okay. So 2.5 by 4.4 into 10 power 10. 2.5 whole square means 6.25. 6.25 by 4.4 is nothing but 1 point something. 1 point something, we have only one option, 1.4 into 10 power 10 centimeter cube per centimeter cube. So the answer is option C. Okay, clear? So NP is equal to Ni square. They have given N already, and P we want to find out. P is equal to Ni square by N. Coming to the next question. In a P type silicon sample, the whole concentration, directly here whole concentration given 2.25 into 10 power 15 per cubic centimeter. If the intrinsic carrier concentration is 1.5 into 10 power 10, what is the electron configuration? So NP is equal to Ni square now. So we want electronic concentration. N is equal to Ni square by P. Ni square. Intrinsic concentration 1.5 into 10 power 10 whole square by P is nothing but 2.25 into 10 power 50. So 1.5 whole square means 2.25 10 power 20 by 2.25 into 10 power 50. Okay. So this one cancelled out. This one comes to the numerator 10 power 5 now. 10 power 5 is answer option B. Okay, 10 power 5 is nothing but answer is option B. Coming to the next question, guys. In the following, which relation is correct based on electrical neutrality? Based on electrical neutrality. What is the electrical neutrality? Neutral. Whenever the positive charge is equal to negative charge, you can say that is a neutral. Whenever the positive charge per cubic centimeter per cubic volume is equal to negative charge per cubic volume. Okay, so positive charge in the sense, come on, positive charge, we are getting the positive charge in case of due to donor impurities, and also P, we are getting the positive charge, and negative charge due to acceptor impurities and electrons. So Nd plus P is equal to Na plus N. Okay. So the answer is option C. Okay. So positive charge we are getting due to donor ions and holes. Negative charge we can get negative. If anyone accept one electron, it will becomes negative now. For example, fluorine is there, it attract one electron, it will becomes F minus. Okay, it will becomes F minus. So whenever anyone accept the electron, it will becomes negative charge. Okay, so acceptor plus acceptors and also electrons. Electrons are negative charge. So positive charge is equal to negative charge. Positive charge, donor ions are positive charge and also holes are positive charge. Acceptors and electrons are negative charge. So LHS is equal to RHS, that is positive charge is equal to negative charge. So hence that is electrically neutral. Okay. Coming to the next question. In the following, which is Einstein's relationship? Einstein relationship is nothing but the ratio of diffusion constant to mobility. dN by mu n is equal to dP by mu p is equal to thermal voltage Vt. Thermal voltage Vt. So dN by mu n is equal to dP by mu p is equal to Vt. Yes, correct. So the answer is option A. This is the Einstein relationship for this diffusion constant with ratio of mobility. In the following, which is correct expression for Fermi Dirac distribution function? F of E is equal to 1 by 1 plus E minus EF by KT. That is option A. 1 by 1 plus E minus EF by KT. Okay, so answer is option A. In pure semiconductor, electric current is due to dash. In pure semiconductor, electric current is due to, here number of electrons is equal to number of holes now. So due to both holes and also electrons. Due to both holes and also electrons. Okay. Okay, students, we will discuss the remaining questions in the next session. All of you, thank you so much for watching. If you like my classes, please encourage me with your likes and also comments and shares. Okay. Okay, guys.